Hello, this is Mrs. Akers, and this is Algebra 2, week of April 20th, 2020, video 2. Today we're going to do some word problems with linear equations, so please write and follow along with me. So example 1. The number of times a cricket chirps per minute depends on the temperature. When the temperature falls to 40 degrees Fahrenheit, the crickets quit chirping. Let me fix that. At 93 degrees Fahrenheit, the crickets chirp 240 times per minute. So that is our situation. Part A, graph the model of this situation. So when we look at this, we have two ordered pairs. We're going to let x equal the temperature in Fahrenheit. And we're going to let y equal the amount of chirps per minute. So we have two ordered pairs. We have at 40 degrees Fahrenheit, we have 0 chirps. And we have at 93 degrees Fahrenheit, we have 240 chirps. So let's look at a coordinate plane of this. X is going to be my degrees in Fahrenheit. And realistically, I don't want to go much past 100. We very rarely get above 100 degrees Fahrenheit. So let's go by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I'm going to go a little above it. 110, 120. I'm not going to go any more than that. And then my chirps per minute, well, I know at 93 degrees I have 240 chirps per minute. So I know I want to go above 240, but not necessarily a bunch above 240. So on my y-axis, instead of going by 10s or even by 20s, let's go by 30s. 30, 60, 90, 120, 150, 180, 210, 240, 270, 300. And let's graph the points we have. We know we have 40, 0, and we have 93, 240. 93 is going to be closer to 90 than 100. Then I'm going to go up to the 240. I'm going to plot my point. And I'm going to think about my line. When I don't know my situation, I always put an arrow on both ends of my line. And in this case, I could still think that I need to go below the x-axis because we can have less than 40 degrees Fahrenheit. But are you ever going to have negative chirps? And the answer is no, not going to have a negative chirp. So really our model ends at this 40 degrees Fahrenheit. Once I hit 40 degrees, I'm not going to hear the chirping anymore. So instead of making a line, I'm going to make a ray. And this represents the amount of chirps per minute per degrees Fahrenheit. Okay, so let's write that down. The line represents the amount of chirps per minute per, there's another per degree Fahrenheit. Okay, so now we've drawn the line. Next, part B. What is an equation of this line? Okay, so here we have decisions to make. We can use slope-intercept form, but we don't know the slope or the y-intercept. We can use point-slope form. Again, we don't know the slope, but we know a point. We actually know 2 points. Or we can use standard form. And it really doesn't matter which one you pick. I'm going to show you point-slope form. Because I can use 40, 0, and 93, what was it, 240, to find M. The formula for slope is the change in the y's over the change in the x's. I have 2 y's, I have 2 x's. So I'm going to take 240, I'm going to subtract 0. I'm going to take 93, I'm going to subtract 40. I'm going to get 240 divided by 53. Now, let's talk about this 240 divided by 53. We can look at it as a decimal. We can look at it as a fraction. Which one makes more sense? I'm talking about chirps per minute per degree Celsius, or degrees Fahrenheit, not Celsius. I think it makes better sense to look at the decimal. So this is about, I'm going to round it, 2.58 more chirps per minute as degree Fahrenheit increases 1 degree. Okay, so the chirps increase 2.58 more as the temperature increases by 1 degree Fahrenheit from that 40 degree Fahrenheit. So now that I have my M, I get to pick. Okay, so now I pick either 40 or 93 240 to substitute into y minus y1 equals m times the quantity x minus x1. So I'm going to do this two different ways. This is the only thing that makes it difficult for a teacher with point slope form, is because there's infinitely many equations that are correct, because there's infinitely many points on the line. So if I use 40, 0, my equation is going to look like y minus 0 equals 2.58 times x minus 40. If I use 93 240 instead, I'm going to have y minus 240 equals 2.58 times the quantity x minus 93. Both of these equations are correct. Both are correct. So this is a situation where you might get something different than your friend, and that's okay, because your friend might have used another point than you used. Okay, so don't get worried if you got something a little different than your friend if you're using point slope form. Now, slope intercept form and standard form, there's only going to be one correct answer. Okay? Alright. Let's do part C. If the temperature is 70 degrees Fahrenheit, how many times would a cricket be expected to chirp in 1 minute? Okay, so we take our equation, whichever one we used. Let's look at our second one. Y minus 240 equals 2.58 times x minus 93. And we have to substitute 70 degrees in. Is 70 degrees the y or the x? Look up here. And 40 and 0, what was the degrees? 40 was the degrees. And 93 and 240, what was the degrees? It was 93. So in my example in part C, I want to plug in 70 for x and I want to solve for y. So on the left hand side, order of operations, I'm going to take 70 minus 93. And I get negative 23. Then I multiply that by 2.58. So I've got y minus 240 equals negative 59.34. Now I'm ready to solve for y, so I'm going to add 240. Remember, you are more than welcome to use the calculator. You do not have to do this arithmetic in your head. So I'm going to add 240, and I'm going to get 180.66. So at 70 degrees Fahrenheit, the crickets will chirp about 181 times per minute. And that should make sense. At 93 degrees, the crickets chirp 240 times per minute. So when I drop down to 70, it should be less, and it is. It's 181 times per minute. Alright, let's look at a different example. An office manager ordered 140 packs of printer paper. Based on average daily use, she knows that the paper will last about 80 days. Part A, what graph represents this situation? Okay, let's look at what we have. An office manager ordered 140 packs of printer paper. So day 1, day 0, time 0. We have 140 packs of printer paper. We know that paper will last about 80 days. So after 80 days, we have 0 printer paper. What graph represents this situation? So we know our y-intercept, which is our starting point, and we know our x-intercept, which in this case is our ending point. So let's look at a graph. X is in days. Let's go by 20. 20, 40, 60, 80. These are packs of paper. Let's go by Let's go by 20, but let me split this. 20, 40, 60, 80, 100, 120, 140. So we start with 140 packs of paper. After 80 days we have 0 packs of paper. I am not going to draw an arrow on either side of that line. It's going to be a line segment. Because I start with 140, I can't go in the negative days. I'm going to end with 80. Again, I can't go in the negative days. Or negative packs of paper, I'm sorry. Negative packs of paper. So I'm going to use a line segment with this graph. Part B, what is the equation of the line? Well, I know the y-intercept, I know the x-intercept, I do not know the slope, so let's start with the slope. The slope is going to equal 0 minus 140 over 80 minus 0, which is negative 140 over 80, which is equal to, we have to divide those, negative 1.75. So that means the company uses 1.75 packs of paper per day. That's the meaning of the slope. I can use point slope form or I can use slope intercept form. It's really up to you. To do something a little different than we did in the last example, I'm going to use slope intercept form. We know our m is negative 1.75. The b is the y coordinate of the y-intercept. It's 140. So we have y equals negative 1.75x plus 140. Remember, x is all the time in between day 0 and day 80. Y are all the packs of paper between the 140 packs to the 0 packs when they're all gone. Alright, part C. How many packs does the company have after 30 days? So y is what we're looking for. X is 30. So we substitute 30n for x. We multiply negative 1.75 times 30 and we get negative 52.5. That means we have used 52.5 packs of paper. We add that to 140 and we get 87.5. So after 30 days, the company has 87.5 packs of paper left. Okay, that is the end of video 2. Please answer the questions in Google Classroom if you are able to get online, and please complete the independent work for this week. I hope everyone's having a good day. If you need anything, please email jennifer.akers@huntsman.org. Please check Google Classrooms for any announcements. Kind of like to have some threads in Google Classroom that's kind of Facebook-ish. I know you guys are more into Snapchat, but I prefer Facebook. So please comment on any streams or threads that are posted there. I will talk to you later. Goodbye.